Ozone creation and destruction. Ozone molecules are created when the stratosphere's O2 is bombarded with highly energetic solar radiation, as well as ultraviolet rays. Once these two mix with each other, the radiation begins to split the O2 molecules into half, freeing the combined O2 into two separate O's. Then, the freed up single oxygen atoms then begin colliding with each other, and eventually form an O3, where three single atoms bond together, thus creating O3, also known as ozone. The destruction of ozone, however, has always happened on its own, with the stratosphere creating its own sort of equilibrium, creating and destroying itself at equal rates. Chemicals such as CFCs, HCFCs, carbon tetrachloride, methylchloroform, and other gases release chlorine atoms and halons that are the ultimate reason for ozone destruction. These chemicals come from everyday things such as coolants, aerosol cans, as well as gas fumes. But humans aren't the only cause for the depletion. Volcanoes that erupt release harmful chemicals as well, like bromine, chloride, hydrogen, and chlorine, that later rise up into the stratospheric ozone and begin to break it down as well.
Okay, so VOX is an abbreviation for volatile organic compounds. They are carbon-containing chemicals which are used and emitted by anthropogenic and natural sources. A few anthropogenic sources are solvents, industrial processes, household chemicals, gasoline, evaporation, and consumer items. VOX also come from natural sources such as volcanoes, vegetation, bacteria, and even trees. An example is the deciduous trees, which emit great amounts of volatile organic compound, isoprene, during hot days. VOC reactions typically occur in the tropospheric ozone, and they are a very big pollutant in indoor air. They react with nitrogen oxide in the presence of sunlight and create ozone. An example of a VOC which has known health effects is formaldehyde. Formaldehyde typically irritates the mucous membrane and causes skin allergies. It results from leakage from presence of pressed wood and insulation. In addition, is actually one of the reasons why plywood has been decreased in use, because health concerns have arisen about its releasing of formaldehydes.
CFC interaction with ozone. CFCs are man-made chemicals that have a significant influence on depleting ozone levels. CFCs were widely used in aerosol propellants, refrigerants, foams, and industrial processes. CFCs are stable and inert in the lower atmosphere and are thus able to travel farther up to the stratosphere. Here, the UV light that penetrates to the stratosphere breaks down and separates the chlorine atom from the CFC molecule. The separated chlorine atom is then free to take on one oxygen atom from an ozone molecule, creating chlorine monoxide. If an oxygen atom hits the chlorine monoxide molecule and takes the oxygen atom, it will become O2 and release the lone chlorine atom. A single chlorine atom can repeat this process over and over up to 100,000 times.
Photochemical smog is a type of smog that is created when there are high levels of nitrogen dioxide in the atmosphere, and it causes this brownish haze to form over cities, which is called brown air smog. It is created through light-driven chemical reactions of primary pollutants and normal atmospheric compounds. Photochemical smog occurs in the tropospheric ozone because this area is abundant in atmospheric compounds that are ready to react. Now, photochemical smog typically comes from anthropogenic sources such as fossil fuel combustion and specifically the exhaust produced by cars. But it can also come from volcano eruptions because when volcanoes erupt, they emit particulate matter and molecules that have the potential to react and create photochemical smog. And photochemical smog has to be created in temperatures that are higher than 18 degrees Celsius. A breakdown of the photochemical smog cycle is that nitrogen is burned and it creates this nitric oxide that, when exposed to UV radiation, water vapor, and hydrocarbons, creates nitrogen dioxide, nitric acid, ozone, and parallax nitrates, which is commonly abbreviated to PANS. These pollutants that are formed not only contribute to photochemical smog, but also end up damaging living tissue cells in animals and plants and contributing to acid deposition. Exposure to photochemical smog can cause respiratory problems such as tight chest, coughing, and inflammation of the lungs.